Now let us go through some numericals on number of particles per unit cell and density of the unit cell. So firstly we shall go for the number of particles per unit cell. In the number of particles in simple unit cell, the number of particles in simple unit cell can be calculated by using the formula, that is Nc divided by 8 plus Nf divided by 2 plus Nb divided by 1 is the formula to calculate the number of particles per unit cell. Here Nc stands for the number of particles which are present at corner, Nf stands for the number of particles which are present at center of face, Nb stands for the number of particles which is present at center of the unit cell. So here the particle which is present at the corner of the unit cell is shared between 8 different unit cell. Therefore the number of particle, the number of corner particle is divided by 8 because 1/8 portion of that particle is belong to the given unit cell. Therefore it is Nc divided by 8. The particle which is present at center of the one face of the unit cell, if the particle present at the center of the one face of the unit cell, that will be shared between two different unit cell. Therefore it is divided by 2, Nf divided by 2. Next, if the particle present at center of the unit cell, it is donated to, it will complete part of that particle is contributed to that particular unit cell. Therefore it is Nb divided by 1. In simple unit cell, the particles are present at only the corner. There are 8 particles per unit cell. Therefore it is Nc, the Nc is equal to 8 and Nf is equal to 0 and Nb is equal to 0. Therefore it is 8 divided by 8 plus 0 plus 0. The number of particles present in simple unit cell is equal to 1. Nextly we shall go through the number of particles in FCC. In FCC the particles will be present at corner of the unit cell as well as center of each face. So here all the particles are present at corner as well as center of each faces. From the formula you can write number of particles is equal to Nc divided by 8 plus Nf divided by 2 plus Nb divided by 1. There are 8 particles at the corner and 6 particles at the center of each face. Therefore it is 8 divided by 8 plus 6 divided by 2 plus there are no particles at the center of the unit cell. Therefore the value of Nb is equal to 0. Therefore the 8 divided by 8 gives 1, 6 divided by 2 is 3 and the Nb is 0. Therefore the total number of particles present in FCC is equal to 4. Number of particles in BCC. In BCC the particle present at corner as well as center of the unit cell. From the formula again Nc divided by 8 plus Nf divided by 2 plus Nb divided by 1. There are 8 particles at the corner, therefore it is 8 divided by 8 plus there are no particles present at the center of each faces of this kind of unit cell, therefore it is equal to 0. There is only one particle which is present at the center of the body, therefore it is equal to 1. Therefore here 8 divided by 8 plus 0 plus 1 we will get 2. The total number of particles present in BCC is equal to 2. Nextly we shall move on to the problems on this concept. In face centered cubic unit cell arrangement, A and B atoms where A are present at the corner, B at the center of face, A atoms are missing from 4 corners in each unit cell. What is the simplest formula of the compound? From the data, the given unit cell is FCC. The atom A and B makes a unit cell. A are present at corner and B are at a face center. A atoms are missing from 4 corners. If A occupies the corner, out of 8 corners, 4 corners are missing. Therefore, there are only 4 atoms at the corner. Therefore, the number of atom at the corner is 4 into 1 divided by 8, which is equal to 1 divided by 2. The B occupies a face center. There are 6 faces and 6 particles will be there. One half of that particle will be contributed to that unit cell. Therefore, it is 6 into 1 by 2 is equal to 3. The number of B atom is 3. Number of A atom is 1 by 2. Therefore, the formula of the compound is A1 by 2 B3. If you multiply it by 2, we will get A B into 3 divided by 2. Nextly, in a cubic type of unit cell of compound, A atoms are at one half faces while B atoms of corner of the cube. Calculate the formula of the compound. From the data, they are telling half faces are occupied by A. That means out of 6 faces, half faces means there are only 3 faces. That is half of 6, and half of that particle will be contributed to that unit cell. Therefore, it is 1 by 2. Therefore, number of A atoms are equal to 3 divided by 2. The number of B particle, there are 8 corner particle, that 1/8 of that particle will be contributed to that unit cell. Therefore, it is 8 into 1 divided by 8, that is equal to 1. Therefore, the formula of that compound is A3 by 2. B is the formula of that particular compound. Nextly, we shall move on to density of the unit cell. The density of the unit cell can be calculated by using the formula, that is usually the formula for the density, the general definition for the density is mass per unit volume. Here we are calculating the density of the unit cell. Therefore, it is mass of unit cell divided by volume of the unit cell. The mass of the unit cell is calculated by the number of particles in the unit cell into the mass of each particle. Mass of each particle can be calculated by its molar mass divided by Avogadro number. The volume of the unit cell is cube of its edge length. Therefore, it is A cube. The mass of the unit cell is given by Z into M divided by Na divided by A cube. Therefore, the total formula for the density of the unit cell is rho is equal to Z into M divided by Na into A cube. This is the formula to calculate the density of the unit cell. Once again, I repeat the terms there, that is Z is equal to the number of particles in the unit cell, M is the atomic mass or the molar mass of that substance, Na is Avogadro number of particle, A is the edge length of unit cell. Nextly, we shall move on to a numerical on the density of the unit cell. Here the numerical is as shown here. The chromium metal crystallizes with a BCC lattice. The edge length of the unit cell is found to be 287 picometer. Calculate its atomic radius. Let us take this part later. let us what would be the density of the chromium in grams per cubic centimeter, given that the atomic mass of chromium is equal to 52. Let us write down the given data. They are telling that the chromium metal crystallizes in BCC, therefore the given unit cell is BCC. If the given unit cell is BCC, the value of Z is equal to 2. Then the edge length of the unit cell is found to be 287 picometer. That means A is equal to, that means A is equal to 287 into 10 to the power of minus 12 meter. We can write 2.87 into 10 to the power of minus 10 centimeters. Sorry, 287 is equal to 10 to the power of minus 12 meter. So if we move the decimal point 2 digits back, we can write it as 2.87 into 10 to the power of minus 10 meter. For next, if we express it in centimeter, we can write 2.87 into 10 to the power of minus 8 centimeter. That means if there is 10 power minus 10, we shall write it like 10 to the power of minus 10 can be written as 10 to the power of minus 2 into 10 to the power of minus 8. Here 10 to the power of minus 2 can be written as centi and into 10 to the power of minus 8 meters. This is A, the value of A. For our calculation, we require A cube. Therefore, we will take the cube of A, which is equal to 2.87 into 2.87 into 2.87 gives you 23.63 into 10 to the power of minus 24 cubic centimeter. From the formula, we have rho is equal to Z into M divided by A cube into Na. The value of Z is 2. The value of molar mass of chromium is 52. Therefore, it is 2 into 52. A cube value is 23.63 into 10 to the power of minus 24 into 6.022 into 10 to the power of 23. That is rho is equal to Z into M divided by A cube into Na. That is 2 into 52, we will get 105, whereas 23.63 into 6.022 into 10 power 23, that is 23.63 into 6.022 is 142.3. 10 to the power of minus 24 and 10 to the power of plus 23 gives you 10 to the power of minus 1. 104 divided by 142.3, we will get 0.73. If 10 to the power of minus 1 comes to the numerator, we will get 7.3 grams per cubic centimeter, which is the density of chromium. Nextly, we shall move on to the next problem. That is the substance form face-centered cubic crystal that the density is 1.984 grams per cubic centimeter and edge length of the unit cell is 630 picometer. Calculate the molar mass of the substance. From the given data, the given unit cell is FCC, therefore Z is equal to 4 and the density of crystal is given, which is equal to 1.984 gram per cubic centimeter. The edge length of the unit cell is 630 picometer. 630 pico stands for 10 to the power of minus 12 meter. 630 into 10 to the power of minus 12 meter. So for the convenience of our calculation, we will write it 6.3 into 10 to the power of minus 8 centimeter. That is because we have to get the cube of A. If we have to get cube of A, if it is 630, it is very difficult to get the cube of 630. Therefore, the 630 into 10 to the power of minus 12 meter is given. So here if we can assume that there is a decimal point after 630. If we skip or if we forward this decimal point 3 digits back, we can write 6.30. The number of digits we have moved is 2. Therefore, it can be written as 630 into 10 to the power of minus 10. 10 to the power of minus 10 means here if we have to express it in centimeter, it can be written as 6.3 into 10 to the power of minus 2 into 10 to the power of minus 8. 10 to the power of minus 2 stands for centimeter. Therefore, it can be written as 6.3 into 10 to the power of minus 8 centimeter. From the formula, we have crystal density is equal to Z into M divided by V into Na. V stands for A cube. On substitution of all the data, we will get the density of the crystal is 1.984 and the number of particles in the unit cell is equal to 4. The molar mass that we have to calculate, then the Avogadro number is 6. The density of the unit cell is 6.3 into 10 to the power of minus 8 whole cube, and the Avogadro number is 6.022 into 10 to the power of 23. If we transpose here, we can write M is equal to 1.984 into 6.3 into 10 to the power of minus 8 whole cube into 6.022 into 10 power 23 whole divided by 4 is equal to 74.70. On calculation, we will get the data 73.70. This completes the numericals on the density of unit cell and the number of particles per unit cell. Thank you.